Gravity is the most reliable, observable force in our daily lives. But at the extreme edges of reality, that reliability shatters. The universe operates on two entirely different, scale-based rulebooks that describe the same reality using completely different logic. For massive objects like stars and galaxies, we rely on Albert Einstein's general relativity. At this macroscopic scale, gravity is smooth. It acts as a geometric curve in the fabric of space that keeps planets and moons on predictable, mathematical paths. But at the subatomic level, general relativity fails. Down there, we use quantum mechanics, a chaotic system where particles don't follow paths, but exist as fluctuating waves of probability. Both frameworks are remarkably accurate on their own, but if you try to combine them into a single equation, the math collapses. This animated diagram shows what happens when these formulas meet. They result in an output of infinity, a mathematical dead end. In physics, infinity is a red flag. It marks a systemic blind spot where our two most successful descriptions of the universe refuse to acknowledge each other, suggesting that something is missing from our understanding of how space actually works. To find the source of this failure, we have to look past atoms and protons and dive toward the absolute smallest possible distance in nature. This animated diagram tracks the descent to 10 to the power of -35 meters. We call this the Planck length. It is the fundamental floor of the universe. You would expect gravity to scale down smoothly to this boundary, holding the tiny structure of space together in a neat mathematical grid. Instead, the equations predict gravity becomes so intense here that the fabric of spacetime itself disintegrates. The universe effectively runs out of space. At its smallest limit, the physical foundation we rely on to define location and distance disappears, leaving us without a framework to describe reality. There is one physical location where these two scales are forced into the same space, the singularity at the heart of a black hole. Here, the mass of an entire sun is crushed down until it occupies an infinitely small point, forcing the rules of the massive to interact with the rules of the subatomic. Einstein's equations predict spaghettification. Gravity pulls so fiercely that it stretches an object into an infinitely thin line. But quantum mechanics refuses to compress. Its particles reach a limit governed by probability waves that cannot be squeezed into a single point. This violates the uncertainty principle. Quantum physics dictates that you cannot pin down a particle's exact position and momentum at the same time, which an infinitely small singularity would require. At the singularity, remnants of a collapsed star occupy a space where the rules of spacetime are forced into a paradox that tears them apart. If you want to track how these conflicting rules eventually resolve into a single system, save this video. We are about to look at the code beneath the physics. Every other force in nature is carried by a particle, like the photon for light, but we have never found the graviton, the particle supposed to carry gravity. Its absence suggests that gravity might not be a fundamental force at all. This points towards emergent gravity. Individual nodes of quantum information form a solid surface by connecting. In this model, gravity is a side effect. Just as temperature is the movement of atoms, gravity is the macroscopic result of quantum information syncing up. This explains the infinite math at the Planck scale. We aren't hitting a physical wall. We are reaching the boundary where the underlying informational code of the universe exhausts its processing limit. When gravity dissolves into raw information, it takes the concept of causation with it. In an emergent universe, objects don't interact because they are physically close. They are physically close because their quantum information is correlated. If the code syncing these objects fails at the extreme scale, the physical link between action and result, the bridge of cause and effect, vanishes. To see how this rewrites the rules of time and destiny, watch our video on the causation gap next. Explore the blind spots with us.